All right. So what you all should have done by now is turned in your game. It'll make you millionaires after you leave here. I think I might try using that iClicker today. So hopefully you've registered for that. If not, get on that easy task. What I wanted to do before anything else today is, well, let me ask questions. Anyone have any questions about anything? That was my weekend. It was about 30 years too short. It was all right. It was good. So, what I want to do is ask if there are any volunteers who want to show off their game. It could be. It doesn't have to be fancy, right? The threshold is not that it's some awesome coin-op game from the 1980s. Just the, yeah, come on up. All right, so here are the IDs. All you have to do is type in GPL, your ID. Let's hit tab. Yeah, let's hit tab again. So just choose whichever. Oh, we're gonna have to. You have graphics, so we're gonna have to dive in there. Why don't you CD into there? All right. So now you can do GPL and run your game. Is it still in the tarball? Go ahead and expand.
Yeah.
Go ahead and.
It's there. It's GPL.
Oh no, it already have one.
Oh, it did. Okay.
Why though? I didn't. Did you do that?
Yeah, my tool did it. I just forgot that it'll expand
okay.
those for me. All right. And so the big question is, what kind of dog is that?
It's my dog actually.
Your dog. He's small.
Yeah, she's half Chihuahua, half Terrier.
Oh, there you go. And so what's the objective here?
So it's like try to dodge the bugs and the birds.
So all the stuff you try to dodge. What about the hearts?
The heart is you can collect, and then you see on the top it tells you how far you're being moved, walked, and then like what's how many heart you collect.
All right.
So
give us another run of it.
Okay. So I need to.
I assume Q. Just go back to it. Hit Q.
Yeah, I can just move up and down. It's like a Flappy Bird, but kind of, yeah. So the thing is, when the heart just touches me, like I keep any points.
Right.
So that's a bug, you know. If you want more points.
Yeah, the kind of the bounding boxes are a bit odd here. All right.
It's not. Yeah, it's not
That's
easy.
good. That works.
Yeah.
Good job. We'll give you a round of applause for being the first. Okay. Who else do we have who's willing to put their gaming programming chops on the line? There's got to be at least like 2 more people. Let's get at least 3 people doing it. I looked at a few of them. There are plenty there that are worth showing. Come on. Nothing? Really? Are you that shy? You don't want to show off? Yeah, go ahead. Huh? Yeah, let's play some Pong.
So player 1, the up and down is W and S. Player 2, up and down is the arrow keys.
Oh! All right. So I'm out of practice.
All right.
So good. Thank you. Thank you for being brave. Anyone else? Give me at least one more person. I know that someone spent like 40 hours working on this, and they're just shy. Not a one? Not one person? There were a lot of good ones. All right, well, that's fine. I'm not grading you on coming up here, so. So again, the motivation for that assignment is, should everything hold true, we will be going through the process of developing a compiler, except we won't be compiling, translating down to a different language. We'll actually, rather than that last step of generating code, instead we'll be running this, right? So all that stuff you wrote will eventually go into a, quote, a compiler that you wrote, and it will run all the routines to actually generate the graphics and have it going and so on and so forth. All right. So by writing a game yourself, you're getting a little more intimate with the ins and outs of that language that you'll be writing a compiler for. So there are a number of steps to the compiling process. I talked about it just slightly, that initially you have a lexer or a scanner that is going to turn this into a set of tokens, and then a step after that is to generate a parser to ensure that what you have here makes sense. So today I wanted to focus on the first part, the lexer or the scanner, which is to take some sort of input and turn it into a set of tokens that is then parsed further downstream. Okay? The first key to being able to do that scanning successfully is to understand regular expressions. How many, has there been any formal treatment of regular expressions in any of the courses before now? No? Okay. I imagine some of you have encountered it. Let me be the first to say that regular expressions is incredibly useful, and it is not because it is used when you build a compiler. Now, it is useful when you're building a compiler and you have that scanner at the front end, but in my professional life, when I was a professional computer geek for a dozen years before changing careers, I used regular expressions all the time, and I was programming information systems, right, database systems and stuff like that. So don't give short shrift to regular expressions. They're extremely useful, and they are incredibly widespread in computer science and software engineering jobs. I provided another link here on the left. One of them is, or I should say the new link I provided is Flex and Bison resources. I will talk about Flex and Bison momentarily. But I wanted to draw your attention to the first couple of links here. The second one is a regular expression cheat sheet, and this one I actually just picked so it's high up in Google. You just type regular expression cheat sheet. There will be 30 to 50 links. I'd go through it and pick one that suits you well. So don't be, I'm not formally advocating this one. This is just low-hanging fruit for me to link to, and it looks like it certainly has a lot of the basic information that you'll need. Also, what is very useful is this right here, which is testing them. And this is a web page that someone created where you can create a regular expression up here, and it'll show you, it actually does a little bit of explanation as to what your regular expression, what all this construct means. It is down here. I found it isn't perfect, but it does a pretty good job on the basic stuff. And this text right here is what this expression is searching for. And I should note that this down here you can edit. So for instance, if you need to test negative numbers with this this regular expression, there is no negative number down here, but I can just type in here and I can say hello negative 53, right? You can add your own text to help test the expressions that you're writing. So a regular expression is kind of the superhero version of wildcard characters. Certainly have some experience where I can say ls, I got a D, that's going to give me everything that begins with the letter E. I want to make a note though that this is actually a different mechanism. So we're running a shell. Specifically, I'm running the bash shell. The bash shell has its own wildcarding features. There are, one, it's very primitive. Two, it's not regular expressions. There are some characters like the asterisk which have a similar, but it is not the same meaning as in a regular expression. So anything you do in regular expressions, or let me say anything that you've done at a shell, these wildcards and so forth, don't assume that the meaning is the same in regular expressions. Regular expressions is its own thing. So you can ignore the slash and the G. That is just a specific usage of a regular expression. What we're all only concerned with is the stuff inside of the slashes there. The dot is the simplest expression. You'll note that every single thing there is highlighted in blue. A dot means any single character. I can look for all letter A's. All right, so this is all fairly straightforward. I can look for all letters A, B, and C. And for that, I use square braces. I can look for, let's see. Note that this changes a little bit. So I have that dot, which means any character at all, and the asterisk means 0 or more instances of that character. So note, that is matching, I don't know, 300 or 400 individual characters, right? So that's 300 or 400 matches of that regular expression. This is about a half dozen matches of that regular expression. It's matching 0 or more, a string of 0 or more characters. And then it ends once we hit the new line. In general, these regular expressions don't cross new lines. You can put ranges. So I had that A, B, and C in here. I can put a range in here. So that'll cover all numbers between 3 and 9. Or all uppercase letters between A and F. All right. So our motivation for looking at these regular expressions is we use these regular expressions to identify different kinds of tokens in our input stream. So the word int, names of variables, the square brace, right? All these things that you were doing in your coding of the GPL game. What I want to do, rather than now I've just given you a tiny taste of it, if we jump back to the assignment /projects, there's another link here, assignment 3. In here I have a bit of an in-class thing. What I want you to do is to use some sort of reference and use this as well and come up with 7 different regular expressions for each of those 7 items. And again, I'm just going to let you work a while and then we'll kind of bring it up here and bust them all out. It's not anything you're going to turn in, so I mean definitely get together with your neighbor and see how quickly you can come up with the different regular expressions for these. That make sense? All right, then I will pause the screen recording and we'll do that for a little while and then I'll bring it back up here. All right. Let's go ahead and do several of these. So hopefully everyone got number one. How do I write a regular expression to find apple? Apple. Okay, first thing we notice about regular expressions is, not first thing, but one of the initial things is they are case sensitive, right? So that doesn't. How about when we have two separate expressions, apple and banana, how do we say an either or? How's that structured? So if I want to look for a digit, I can do that, but that's probably, let me see if I can zoom this in. So that's finding 6 different matches, and what I want are 2 matches, right? I don't want a 9 and a 6 and a 2. I want 962. So rather than finding a single digit, I could do something like that. That finds them, but that's peculiar to 3-digit numbers, and obviously our integers could have more or fewer than 3 digits. So how can I generically say I want 1 or more digits? Plus. So plus is specifically referring to whatever comes before, right? This would be 1 or more letter A's. So this is 1 or more digits between 0 and 9. Now, so that succeeds that, right, is successful there, although we don't have the minus captured. Now I can throw a minus in here and that finds that, but now that's not finding our 962. So one thing we could do is, and this is not the strategy we ultimately want, but have you come across the specific symbol to say we want 0 or 1 of the previous? Question mark. So that'll say 0 or 1 negatives followed by 1 or more digits. All right. Now the reason I say we ultimately don't want that is I don't have it here as a test, but that isn't going to pick up the positive sign. So I could go if I want to actually look for a plus symbol, I need to change this. What's wrong with the plus unadorned like this? Plus already has a special meaning, which means 1 or more of the previous, and it's already got a question mark there. So this, you'll note a red line there is saying that we have a syntax irregularity. You can't have 1 or more of something where you have 0 or more of something just before it. So that's why we have the error. How do we tell this thing that we're looking for the plus sign specifically and not taking it in its regular expression meaning? All right, escape it or quote it. Put a backslash to make it a literal plus. Now that'll say either 0 or more negative signs, or 0, I'm sorry, not 0 more, 0 or 1 hyphens and 0 or 1 plus signs followed by 1 or more digits. That isn't going to quite do it for us because let's see, how can I do that? Right, so that's picking that up as an integer, and that isn't quite what we want either. So we want one or the other. How do I specify if there's a pool of characters, and right now my pool is only 2, a negative sign and a plus sign, how do I specify a pool of characters I'm looking for? It's actually already up there. How do I find a pool of digits? I just put them in square braces. Also note that this is a shorthand convenience. I could go right, that'll find all 10 digits as well. So the hyphen is just a convenience for specifying ranges. So 0 through 9. So I can use, I want to find a character somewhere in that pool, and how many of them do I want to find? 0 or 1.
What's the difference between doing that with the square brackets and that if you have parentheses in there?
Parentheses is kind of a grouping. It can help deal with if you have issues with precedence of operators. So just like parentheses normally operate, right? That way you do that?
Yeah. Well, I did the, and then I did a height in the middle, so 4
Oh, all right, right. So that, something like that. Mm-hmm. Frequently, you'll be binding it together with the or if you have something complex like the apple or banana, something longer. If you just got a pool of single characters, then it makes more sense to just throw them in the square brackets. Yes?
Is there a way to eliminate leading zeros with this? Because this currently picks up numbers that start with 0, wouldn't it?
I would assume so, yeah. So, but that's in our case, that's a valid number, right? So you want to avoid the leading 0?
I don't know if that's.
Yeah, we can try to do that. Ask me again after we look at a couple of the others and introduce something, and then we can. I'd have to play around with it, but I think I have a strategy, but it involves some of these other items here. Let's pass on double for the moment. Anything? All right, let's go to 6 and 7. The word the appearing at the end of a line. So how do I say that I'm interested in only the that appears at the end of the line? Yeah, oh, I gave it away. Look at that. Holy smokes. There. Oh, yeah.
They have a flag box on the right side of the screen.
Say that again?
On the right side?
Yeah.
There, yeah, flag.
Is this thing? There it is.
You just put an M after the G.
Beginning of the line? Did that do it? Did I click the
I
right?
think you did, but I think your text one line.
I can't. It keeps. Stop that. All right. the beginning of the line is the caret. The caret has an interesting alternative meaning when it's used in the square braces. So again, what does that mean? I'm sorry, let me make it bigger. Yeah. That's right. Any T, any H, any E, right? And that's matching a single character. How do I negate that? I want to find everything except letters T, H, and E. Right. And so this actually ends up being a fairly common technique when you need the vast majority of stuff except for certain characters. I would say where it ends up being very common, I want everything except the space bar, the tab key, and new lines. So now this gets me everything that is not white space. Right, so that's a fairly common one that you see. Where does that take us? All right, so then this becomes answerable. Anything that is not the digit 3, the letter X, or the letters J through P. So anything that is not the digit 3, the letter X, or the letters J through P. No, so once you're in square braces, this is one area where your intuitive desire to say make things nice by putting spaces in there and so forth breaks down. Anything in those square braces is being interpreted literally. So if I throw, for instance, right, what I've done, now I've got a redundancy, but it's saying also things that are not spaces. Space is just another glyph that's inside of square braces here. So if that should eliminate the pipe from being seen. How many people got the double? 2, 3, very small handful. Well, I'll leave that as a bit of a challenge. It's going to crop up again, so put that on your to-do list to come up with that. We'll talk about it again. All right. So back in the day when compilers were new and exciting, like the 1950s into the 1960s, the initial compilers were no one knew. No one had ever done them before. No one knew how to. And there was the entire compiling process. There was a lot of time spent figuring out how they work and how they should be done. And eventually, there's some things that got figured out and became, in essence, standardized on. And those first two steps of scanning and then parsing are very much water under the bridge. We've done a lot of research, published a lot of papers. We've stroked our chins and feel we've got it down. As a result, there's virtually no one, except maybe some oddball researcher somewhere, actually writing these scanners and these parsers from scratch. They're tools that were developed to help us out, make it a lot easier. And traditionally, the two tools that were, let me see, what can I do here? And this literally meant yet another compiler. So this would do the scanning and this would do the parsing. This was in the Unix world, and with open source coming of age, I don't know, I mean definitely by the early 90s, I don't know if they existed before then, but these gradually got replaced, and as with the really kind of dad humor that programmers have, the version that is in essence supplanted Lex is called Flex. So this is what we know and love today. And Yak looks very close to a buffalo or bison. This is also what we know and love today. So nobody, I can't imagine it. There could be somewhere some really old outdated software that uses Lex and Yak, but by and large everyone nowadays is using Flex and Bison. And this is what's going to do your scanning, and then this is what will do the parsing. Okay. Now I guess let's just jump right into it. So .l extension used by Flex, .y extension used by Bison. Assuming you've got some sort of programmer's editor, you should have nice syntax highlighting if you've got those extensions on your files. There are 3 parts. I can't put the comment there. If I can go. Yeah, I'll just leave it like this. Rules in the form of action, pattern action. And down here is user code. Okay. So this file is what is going to be passed into the, I need to jump to, hang on, let me do this. So the Flex execute it's taken from standard in. This format file is what goes through Flex, and what it generates is it generates C code. Now the C code's pretty good about compiling with C++ now. Okay, but the idea is it generates code, and then that code gets compiled, and that comprises your scanner. Now, you can deal with it in standalone mode, and that's how we're going to start looking at it, where we provide a main and we compile it and we can run it. Once we link in Bison, these two become connected together. It goes through the scanner to come up with these tokens, and then it immediately goes into the parser that parses it apart, and there will just be one executable with the two combined together, one main function, right? But when we take an initial look at it, we will actually write our own main function. So let's try it. Anything in here? All right, let's call this first.l. We don't need any definitions. The only thing we probably really want are some rules. And this is the pattern I'm going to look for. All So this isn't going to work, but let's go through the process. And then you can have stuff down here. We'll look at that momentarily. All this, again, is user code down here. Anything you type is, remember, this generates code. Anything you type in this last section literally is just put wholesale into that code. So you put your own functions and things like that. It doesn't look at it, doesn't analyze it. You can put a poem in there and it'll go ahead and throw the poem into your code. Okay. So now when I try to compile this, again, I want to look for I'm scanning input. So what is ultimately your input? Ultimately, your input is going to be that game that you wrote, right? That's what you're scanning, trying to figure out the tokens. Int, that's a type specifier. Float, that's a type specifier. XYZ, that's the name of the integer. Those are the tokens that you're going to be identifying when you're scanning. This won't be complete. It should not compile. Now, that ran successfully, and note that it created a C file. Okay, and that is, by tradition, the name of the C file. The YY, everything, and you'll see what I mean in a moment, everything has YY in it. Let's look at this code, and let me explain why. No pun intended. YY, amount of matched text. YY, cbuff p. A lot of this code you never look at, never need to worry about, but you'll notice that everything begins with the two Y's. And this goes back to historical reasons. If I am going to create a generic tool that generates code that everyone's going to use, then I'm going to run into problems if the code I generate creates functions with the same name as your code, right? So if I use words like parser or string size, things like this, then it's fairly likely if you have a complex application, I'm going to immediately collide with your names. So their way around that. If we're doing it now, if we're doing this all from scratch now, what we'd probably use is C++, and we'd use namespaces. I would put all of my flex code into its own namespace, and then it couldn't collide, right? But that isn't the way it was back then. So in order to get uniqueness, they have YY everywhere. And so that's just something we have to end up hassling with. We're just about out of time. Let me see if I can get this working. No, it won't work. I haven't compiled it. G++. All right. I'm sorry. All right. Let me put this to the top. Okay, so cout was not declared. This looks familiar from 111. So what is it that we need? All right. So up here, we can provide some code that gets passed on that will ultimately end up inside of that lex.yy.c. And so I can put #include iostream. And I could put using namespace standard. I'm gonna avoid doing that, and I'm just gonna do that. You can do it either way. Also, let me note that the definitions here expect a % on the very first character in the very first column, and there are various commands that you can give to the flex utility to do this or that. So for instance, there's like option, no YY parse, or something, things like that. If you want to put your own code that just gets copied verbatim, you either start it and end it with these special commands, or if it's indented, that'll do the same thing. You usually see it this way. Let's try doing it. I have to run flex. I know we're out of time, so I'll have to continue this. This won't quite do it. Note that we have, what kind of error is this? Who's complaining in the compiling process? Anyone know? Here's the hint. Who complains about undefined references? All right, the answer is the linker. We'll just pick up here next time. No, it's not.